Okay, today is section 4.1. We're going to talk about polynomials and what the equations look like and what the graphs look like. A polynomial is, it's a function, and what it is a smooth curve or a bunch of curves that continue with no breaks, sharp corners, or turns, okay? So if you see a picture that looks like these three right here, these are not polynomials. You should be able to draw the curve without lifting your pencil. There's no corners, sharp corners, no turns, no straight lines, and no breaks. Now, what does a polynomial equation look like? Well, all of your powers, all of your exponents are whole numbers. So that would be a polynomial. Here are several examples of polynomials, what they look like. There are several examples. See this number 12 is 12x to the 0 power. You should all be familiar with the degree. The degree is the highest exponent. So this has a degree of 7, this has a degree of 3, this has a degree of 0, and this has a degree of 9. The leading coefficient, you're going to need to know what that term is in tomorrow's homework. We're going to talk more about leading coefficient. That's the number in front of the term with the highest power, which gives you your degree. So if I asked you what's the leading coefficient, it's 6. 1. In this one, it's going to be 12, and then 1. The constant term is the term that does not have a variable. So in the first one, it's 10. This one is 0. 12 is your constant, and negative 4. So check out problems 1 through 8. We're going to do these together. Can you tell me which one of these 8, there's more than one, is not a polynomial? Which ones are not polynomials? 6 is not because of the square root of x. 7 is not. 5 is fine. You can have a radical. You can have that. You can have that. You can't have number 4 is not a polynomial.
Wait, why is it number 4?
Because it says 7 to the x power.
Oh, okay.
You're not going to have variables in the denominator of a fraction with a fractional exponent or under a radical or as an exponential as a power.
Okay.
Okay, 8's fine. Yep, 8's fine. Now, they also want to make sure, could you tell me how to write these in standard form? Would you know the constant? Would you know the degree? Like, for example, this one right here. If I asked you, what is the leading coefficient? What would you
1.
say? It's a 1, not because of this one, but because this should be written as x to the 3rd plus 1. So the degree is 3, the leading coefficient is 1, and the constant is 1. Okay? Now if you skip to number 3, and by the way, this negative 7 is just like 12. The degree is 0, the leading coefficient would be negative 7, and the constant would be negative 7. For number 3, you would have to definitely FOIL this out. X cubed, and then you have plus 1x minus x squared, and then minus 1. Now, is this in standard form? No. If you wrote it in standard form, this is what you would get. The degree is 3, the leading coefficient is 1, and the constant term is negative 1. So, do you think you guys are okay with that?
Yeah.
Okay. Next. What our goal is over the next few days is we are going to take, this is 2 polynomials. They're asking you to factor it or divide. So this is a polynomial and so is this. We want to divide this into that. Now, long division will help you do any problem. But we can do synthetic division. And we started doing synthetic division last year in Algebra 2. Let's see if you recall what to do with synthetic division. This is called the divisor. what do you do with the divisor? You're gonna take the opposite, which is 2, and in a row here, what are we gonna list?
The dividend.
All of the dividend coefficients, excellent. So you have 3, then what?
0.
0,
Yeah.
-8,
Minus.
-11, and 1. So how do you perform synthetic division? Tell me what to do.
Carry down.
You bring the 3 down, and what do I do with these 2?
Multiply.
Multiply,
Add it.
add,
Multiply.
multiply, add, multiply, add, and multiply. What do you get for a remainder? -5. Questions? So now, can you interpret this answer for me? What's the answer gonna be? 3x to the what power? Third, you're gonna go 1 degree less than this dividend. So 3x cubed plus 6x squared plus 4x minus 3, that's your constant, with a remainder of 5 over x minus 2.
Okay.
You put your remainder over the divisor. Okay, so we're gonna try the next 3 together. Number 9. Help me out, what do I do?
Here, you the opposite of that.
You take the opposite, and then do what?
Now you take the dividend.
Tell me what numbers to put across.
3,
3,
-8, 0, 9, 5.
okay, then what?
Carry
Bring
that.
down,
3, yeah.
and then do what with these 2?
Multiply and
Multiply, then add.
add.
Multiply, then add. Multiply, then add. Multiply, and then add. So please interpret my answer.
3x cubed.
3x, we're gonna go 1 degree less than that.
2x squared minus 4x plus 1. And then
With the remainder of 7 over.
x over 2. Or minus 2.
Perfect. Number 11. What number do I put outside?
-3. 2,
2,
5,
5,
0,
0,
-2,
-2. Good. Then what?
Carry that 2 down.
Bring down the 2.
-6.
Mm-hmm.
Add -1.
Then,
Multiply it.
what's that?
25.
25. So what's my answer?
2x.
2x
Third
to the third
minus 1 squared.
plus 3x.
Minus 11. 25 over x plus 3.
And one more. What number goes outside?
7.
7. I think that's a 2.
That is
So 5,
0.
0, -3,
-4,
-4, and 6. Okay, bring down the,
5,
and then do what?
35.
Then add.
Oh,
Ooh, it looks like we're getting into some big numbers.
35 plus 245.
So 35 times 7, good job, 245. Then add, you get 242. Multiply,
You can do that one.
1694. Add 1690.
That's painful.
Wow, 11,830. So what's my remainder?
It's even real. 11,830.
So what's my answer? 5x to the,
cubed
5x cubed
minus 35
plus 35x squared plus 242x plus 1690 with the remainder of 11,836 over x minus 7. So far, okay?
Yeah.
Okay, now,
Are you gonna give us ridiculous numbers like that?
No.
Let's do it.
more like these two.
Okay.
Okay. Now, you can't do synthetic division on any problem you want. You can do long division on any problem, but you can't do synthetic division. When you're working with synthetic division, the divisor, which is this right here, has to be a degree of 1 and a leading coefficient of 1. This one is not. So we're stuck doing long division. So we're going to do long division on this one. Long division seems to be the hardest for you guys. Now, the first thing you do with long division is set up your problem. When possible, if the dividend does not have, if it has a missing term, I would highly suggest you put in a 0 for a placeholder. So now your job is to figure out 2x squared times what is going to give me a 6x to the third. So what number and letter or combo do I need to get a 2x, to get a 6x cubed? 3x. So now you're going to take this is we're getting our quotient, which is our answer. You're going to do 3x times both of these. Well, if you multiply this, you get 6x cubed, and this is going to be plus 3x. Now, if I put plus 3x here, when I go to subtract, you're going to get confused. So don't put 3x there. Put it right underneath its like term. So this is 0x. We have a plus 0x. So leave a placeholder for 0. So now, what do you do with these two polynomials? You subtract them. So what's 6x cubed minus 6x cubed? Nothing, and that's what you want. What's negative 4x squared minus nothing? And what's 3x minus 3x? Nothing x. Now you always bring the next term down, which is a negative 2. Now we want to know 2x squared times what is going to give me negative 4x squared? Negative 2. So now you're going to multiply negative 2 times both of these. You get negative 4x squared minus 2. Now I'm not going to put minus 2 here. I'm going to put it here. So now if I subtract these are gone, and negative 2 minus a negative 2 is 0. What is my remainder?
Minus a negative 2.
Oh, yeah.
Negative 2 minus a negative 2 is a 0. What's my remainder? None. So the question, go back.
It's a factor.
It says determine if this is a factor of this. Yes, it is. Because there is no remainder. So the answer is yes. Now, how could you check this to see if it works? If you multiply your quotient times your divisor, you will get your dividend. Okay, so let's practice the next one. They want you to use either synthetic or long division. On 17, synthetic division's easier. Can I use synthetic division? Okay, what do I do?
Yes, you're going to draw a little box.
Outside of your box, you're going to put the negative 1,
There's the opposite of that.
and then what goes inside?
3, 0, 2, 6, 1.
Okay, what do I do?
Bring it down.
Multiply, multiply, multiply. So what's my answer?
3x cubed minus 3x squared plus 5x minus 11 plus 12 over x plus 1.
Okay, so they want you to find this is the divisor, this is your quotient, and that's your remainder. Now, on number 19, can we do synthetic division? No. The leading coefficient is 1, but we have a degree of 3. So what are we going to do?
Put your divisor on the outside.
It's your divisor,
Dividend in there.
and we have x to the 5th.
X plus 1.
X squared 5x plus 1. This is a long one. All right, so now, I need x to the 5th power. So x cubed times what gives me x to the 5th?
X squared.
Now, I'm gonna put x squared right above the x squared term. So now when I multiply these two, I get x to the 5th plus x squared.
Where'd you get that 2x squared?
Huh?
Where'd you get that 2x squared? In the,
Oh, you know what? I copied it wrong. Thank you. Copied it wrong. That's it, it's x squared. Thank you. That's x squared. I don't know why I wrote 2x squared. Is everything else right? Yeah. Okay, so now, are you with me on x squared times x to the 3rd is x to the 5th? And this times this is that, x squared. So now when I subtract this is gone,
And that's gone.
but this is not gone. We have to bring 2x to the 4th down. And we have to bring negative 6x cubed down. We do not have an x squared. But we do need to bring the next one in line down, which is minus 5x. Are you with me?
Yes.
Okay, next. I need 2x to the 4th. So what's missing? 2x. 2x times x cubed is 2x to the 4th, and 2x times 1 is 2x. Now, when I subtract these, what do you get?
6x.
What's this gonna be?
Negative 7x.
Negative 7x, good. And now bring down the 1. Now, what do I need here? I need a negative 6x cubed. Negative 6
Sure.
times x cubed is negative 6x cubed. And then I have no x squared. I have no x, and I have negative 6 here. So what's going to happen, these are going to cancel. Nothing's here. I have negative 7x. What's this going to be?
Plus 7.
Plus 7. How'd you get plus 7?
Oh, you multiply by that negative.
Because you're subtracting, and 1 minus a negative 6 is 7. So what's your answer? The quotient is x squared plus 2x minus 6 with a remainder of negative 7x plus 7. Last one, number 21.
You don't throw that like negative 7x plus 7 over that one in long division, do you?
Yeah, well, you put it next here, and you're gonna put it plus, your answer should be this plus negative 7x plus 7 over x cubed plus 1.
Okay, so you're still throwing it over the.
Yes, yeah, you're bringing it up. So this is how I would write that answer. I would write x squared plus 2x minus 6 with a remainder of negative 7x plus 7 over x cubed plus 1. Just like that.
Okay.
That's your answer. This is your quotient, this is your remainder. The last one. This one needs some room. X squared minus x plus 1 is your, I'm gonna erase, I'm gonna write this one up here. Looks like I have more room here. Okay, right there. So, your divisor is x squared minus x plus 1. And then we have 5x to the 4th. And I'm going to put 0x cubed. 5x squared. 0x plus 5. Okay, next.
5x squared.
5x squared. Thank you, Nick. 5x squared times this trinomial is going to give me 5x to the 4th minus 5x cubed plus 5x squared. When I subtract, these are gone. This is going to turn into what kind of 5x cubed? Positive. These are going to cancel, and you're going to bring down 0x. Now, what times x squared gives me 5x cubed? 5x. 5x times x squared is 5x cubed minus 5x squared plus 5x. When I subtract, what happens here? These cancel. What does this become right here?
Plus
5x squared, what does this become? Minus 5x. What am I gonna bring down? A 5. So what do I have here? What happens? You get 5x squared
Cancel completely.
minus 5x plus 5. Guess what? These cancel completely. There is no remainder. So the quotient is 5x squared plus 5x plus 5. Okay? Next. Do you guys remember the remainder theorem from last year?
Hardly.
If you can do synthetic division on this problem, now would you even want to divide this out? No. This is x to the 79th power. It would, if you did synthetic division, you'd have a 1, 0, 0, 0, 0, 0, 0. You'd be there forever. But we could find out if this goes into this or not. And if it does, there should be no remainder. If it doesn't, we could figure out what the remainder is by using the remainder theorem. Now I believe this says x minus 1, right? You're going to take, just like you did with synthetic division, you're going to take the opposite of this number. It has to be in synthetic, the divisor has to have a degree of 1 and a leading coefficient of 1. You're going to evaluate this if x were 1. So you're going to think of f of 1. So if you were to plug a 1 in here, you get 1 to the 79th power plus 3 times 1 to the 24th power plus 5. So let's do this. If I multiply the number 1 79 times, what do you get?
1.
1
Plus 3.
plus 3 plus 5. What do you get when you add these up? 9. So does this go into this? No, it does not. We will have a remainder of 9.
Wait, so what are you looking for then?
It says find the remainder. The remainder is 9.
So, if you end up coming out with 0, you do like no remainder.
Right.
Okay.
This question says find the remainder. So same with example 5. It says find the remainder. So what are you going to do?
You're going to take a negative 2. And then
You're
plug
going
it
to
in
put
for-
negative 2. Good.
F of negative 2.
So do negative 2. If you plugged in negative 2 here, f of negative 2, you would get 3 times negative 2 to the 4th minus 8 times negative 2 squared plus 11 times negative 2 plus 1.
50.
This is going to be 16. 16 times 3 is 48. This is going to be 4, negative 32, minus 22 plus 1. Add those up, what do you get? Really? I got negative 5.
Oh, I got it.
48 minus 32 minus 22 plus 1. I got negative 5. So what is the remainder? Negative 5. Okay, you try 31. It says find the remainder.
1 plus.
So
There
we're
is no
dividing
remainder.
this into that. What are you gonna do?
You're plugging in negative 1.
Not negative
Or 1, positive 1.
1. So what's 1 to the 10th power plus 1 to the 8th power?
Isn't it negative 1? Because there's...
That's a negative 1, you do the opposite.
Oh, I thought the equal sign was a negative. It looked like in the problem. It looked like a negative, so I was like,
Oh, I see what you're saying right here.
yeah.
That's an equal to.
Okay.
Sorry, these are from the book. Copy is not that great. Are you good?
Yeah.
Okay, 33, what would you plug in?
Negative 1.
So 3 times negative 1 to the 4th power minus 6 times negative 1 cubed plus 2 times negative 1 minus 1. Okay, what does this go to?
1.
And 3.
Well, that goes to 1 and then
6.
3. And then this is gonna be positive 6, right? Minus 2, minus 1.
6.
6. Excellent. So what's the remainder? 6.
You don't have to write them any like certain way. You can just write the number, right? For the remainder. Like you don't have to put it over anything.
No,
like,
They just want the remainder. How about 35? What are you gonna plug in?
-2.
So quickly do this for me. Negative 2, and I believe this is x cubed. What'd you get? I got negative 30 as well. Number 37 is gonna be a good one. Why is it gonna be a big one? Because it's 10. So you're gonna do 2 times 10 to the 5th power minus 3 times 10 to the 4th power plus 10 to the 3rd power minus 2 times 10 squared plus 10 minus 8.
200,000.
So this is a 2 with 5 zeros. 1, 2, 3, 4, 5. This is a 3 with 4 zeros. 30,000. This is a 1 with 3 zeros. 200 plus 10 minus 8. Anyone have that answer? 200,000 minus 30,000 plus 1,000 minus 200, and then I'm just 2 plus 2. This is what I got. 230,802. 230,802. Did anyone get something different? Is that what you got?
It's minus 30,000.
Oh,
It should be
that's
like
minus wrong.
1,700.
So it's two, can I go back and alter? No, I guess I can't. 200,000
Oh, what, 100, whatever, shut up. You know what I mean.
minus 30,000 plus 1,000 minus 200. Now is it right?
Yeah.
170,802.
Mhm.
170,802. What's that number? That's the what? Remainder. Remainder. Now, 41, 43, and 45 are the same question, but it's just asked differently. It says use the factor theorem or the remainder theorem to determine whether h of x is a factor of f of x. So what are they asking you now? They're asking you, does this go into this evenly? So if you're able to, they're just asking you, does this go into this? So all you have to do is evaluate this for f of 1. Well, what's 1 to the 5th power? What's 1 plus 1? So my question is this a factor of this? Will x minus 1 go into x to the 5th plus 1 evenly? No, it will not. There will be a little baby 2 as a remainder. So the answer to this question is what?
No.
It's not 2, it's no. No, this is not a factor of this. Whereas the previous question said, what is the remainder?
So you're doing the same thing, but just looking for a zero.
You're just looking for if it goes into it evenly. Now, what if I said, determine whether h of x is a factor of f and x, and if not, what is the remainder?
Then you'd say.
Then you say both. You say no, remainder's 2. So on your test, it's gonna ask you for both. So you tell me how to do this one. I wanna know whether or not h of x is a factor of f of x. What are you
Take
gonna
that
do?
-2.
Negative 2
Looking for x.
cubed minus 3.
Negative 2 squared.
Minus 4, -2, minus 12.
Okay, what do you get?
-8 minus
What's this?
-8
Negative 8
minus 12
minus 12
plus 8
plus 8.
0. Or no, you're gonna get -20.
These cancel,
Negative.
but you get negative 24. So the answer is
No,
No.
-20.
no. And 45. Last one.
Take that 1
You're gonna plug 1 in. So 14
minus
times 1 to the
65
99th
plus
power
51.
minus 65 times 1 to the 56th power plus 51. So what's this go, what does this go to?
14 minus 65 plus 50.
And I believe that is that 0?
Yeah,
That is a big fat 0.
so yes.
So yes. Absolutely. This goes into that evenly. Okay, we're gonna just look at, I'm just gonna show you really quick. How would you type 47 and 49 in your calculator? How do you do this? Well, we know. We're gonna type in 6x raised to the 3rd power minus 7x to the 2nd power minus 89x plus 140. We did this in chapter 2, right? Now, if I hit graph, I have no idea what I'm gonna see.
An N.
You're gonna see something like that. Now, if you change your window, you will see, this is a 10 by 10 window. This thing is shooting up and it's coming down and it's going back up. These 3 are the zeros. That's what we're gonna be concentrating over the next few days, is taking polynomials and finding the zeros. So if I gave you this problem from chapter 2, section 2.1, how would you find the 0? You'd hit second, calc, and then 0, do your left and right bound. Do you remember that? This is a review from 2.1. Okay, same with this one. You would find your zeros, but since we're running out of time, we're gonna just go to the back. We're gonna talk about the zeros. What are the zeros? If I gave you a picture of a graph, and I said, this 0 is -5, this is 0, this is 4, and this is 7.
You plug those in.
Could you write the polynomial that goes with this?
Yes.
What would it look like?
X plus 5,
X plus 5,
X,
X,
no, X minus 4, X minus 7.
so you remember this, we did this last year.
Yeah.
Now, the degree of this is a 4. You count the degree of each 0.
That's how the answers each.
And we're gonna talk about, remember the max and the mins, the left and the right behavior, that's in section 4.3. But today, this is easy, all I want you to do, I want you to name a polynomial that has a 0 at 1, 2, 3, and -5.
Okay.
Can you give me that polynomial?
X minus 3,
Did you say x minus 3?
yeah.